Okay, so the yellow paper that you're receiving is what I want you to look at right now. So if you can set the green packet, which is your Chapter 2 test review, aside, if you can focus on the yellow packet, I want to make sure we kind of understand what's expected of us for the project. The project will go into your formative folder. That's where your quizzes go. It will go in out of 50 points. So it'll be worth like 5 quizzes. Okay. It will only be graded one time. So it's due on Friday. You want to have it finished and ready to go on Friday. Okay. I would say, like, I worked on my project, and I would say I'm estimating about an hour of your time. So it's due on Friday. Whether you do it all in one night or you kind of spread it out between different days, that's totally up to you. But it's going to be about an hour. Now, if you're not following directions or if you haven't been paying attention to polynomials, maybe add a little extra time. Okay. But overall, it shouldn't be like some exhaustive project like you might do in another class. It's just kind of like a nice activity for you to do with polynomials. Okay. So you're going to make what we're going to call your birthday polynomial. So you're going to put your birth date in number 1. So it says write down your birthday in the following format. If you were born on a single digit month or a single digit day, you put a 0 in front. Okay. You guys were all born in like 2002, 2003. Okay. So 2004. Okay. So you have you have lots of zeros in there, which will be kind of nice because it gives you some interesting multiplicities, okay, as you're looking at your graph. Okay, now just listen for the rest of this, and then if you decide to work on your project today in class, you can do that. Okay, in step 2, you're going to write your polynomial in a factored form using your numbers and your birthday as the zeros. So notice in this birthday format, we have 8 numbers. We're going to separate out, so don't use, if you were born on the 25th, don't use the number 25 as your zeros. Use a 2 and a 5. Okay. I'm not telling you if it has to be a plus or a minus. You get to choose that. And that's really something, I would say at that point, you should be on Desmos and, plugging it in, because Desmos will just make the polynomial for you, and you'll be able to see, oh, I like the way that looks, or no, I don't like the way that looks. Let me change this to a plus or a minus or multiplicities, those types of things. So, look at your birthday. If you have repeating digits in your birthday, which most of you do, you could potentially have some multiplicities. Like if you were born in 2002, you could do an x minus 2 squared, or you could do an x minus 2x plus 2. So you'll play around with those things and see if you like the way your polynomial looks. I showed that I did that. This is not my birthday, FYI. I'm not that old. Okay. This is Sir Isaac Newton, father of calculus. Okay. So this is Sir Isaac Newton's birthday. And we went ahead and we kind of modeled how we would write out our linear factors. Notice that once we wrote out the linear factors, we could write the x squared and the x minus 1 squared. So you might have some of those things. Now, at no point, just FYI, do you actually have to multiply this all out. So you can work in the factored form in Desmos and you'll be fine. Okay, so you'll kind of pick, I would check to make sure that you like the shape of your polynomial. Now, notice in number 2, it does have this little statement that says, yikes, this polynomial is crazy, exclamation mark. This is because, and I'll show you here in Desmos in just a minute, when you type it in, the numbers, you have so many zeros that the numbers are really big, and your mins and maxes, for some of you, can be out in the thousands. I had some people 3rd hour who got some in the millions just because of the numbers in their birthday. Now, some people put in their birthday polynomial and they were like, do I really need to even change mine? And I was like, no, it looks great, because they had so many repeating digits. So it varies from student to student. You'll know when you type it into Desmos if you need to scale it down. Okay. Now, we used 1 over 200. So think about that, what you know about stretches and shrinks. That's vertically shrinking your graph, okay, by a factor of 1 over 200, which is pretty small. But we did that so we could bring our like minimum up. It was like in the thousands, and we didn't want it to be there, so we brought it up to like the 500s, or no, it was like 100 or something. Okay, so it'll all depend. I can't tell you what your leading coefficient is going to be if you need one or not, because your birthday is different than my birthday and Sir Isaac Newton's birthday. So you're going to play around with it. Okay. Then you start answering questions. What's the degree? What's the left and right hand behaviors? Honestly, 3 and 4 you don't even need a graph for. But 5, 6, 7, and 8, when you get to these questions, max and mins, x and y intercepts, domain and range, increasing, decreasing, this is where Desmos is king. Like, you should have figured it out and put it into Desmos and maybe even drawn your graph on paper at this point. So if you draw your graph first and then answer 5 through 8, you're probably going to be in a pretty good position to get those done quickly. Okay, and then 9 through, 12 or 11, they ask some really good questions. So I'm going to show you my Desmos. Let's see. I'm going to show you without the 1 over 200. So this was like Sir Isaac Newton's birthday polynomial without the 200. And I've probably changed my x scale, but if I change my y scale, you can go to the wrench in the top right corner. I'm going to make it like negative 5,000 maybe, just to see where we're at. Okay, see, like, look. I put that window at negative 5,000 and it's still going down, right? So like that's what we mean when we say like, yikes, this polynomial is out of control. Let's shrink it up so that we're not using such big numbers. So we went in and we put in 1 over 200, okay? And notice, like this is still on a scale, like here's negative 2,000, here's negative 1,000. That shrinks up my mins and maxes quite a bit. But now I've changed my window so I don't really see a good depiction of my graph. So I can go back to my wrench and I can change it. So like, let's see, probably can go to like negative 200 it looks like. Oh, sorry. Delete. And maybe just like, delete, maybe like 50. Okay, see, this is much more reasonable once I kind of like scale it down. I'm going to show you here in a little bit on the iPad how you can use, I would use Desmos on my phone or like an iPad or something at home if you have one, because you can use your fingers on the X and the Y axis. So not like just like out in space, like a zoom in and out with the pinch. If you do it on the X and Y axis on your phone in Desmos, then it like just changes it vertically. Or you can pinch it in and out on the x-axis and it'll just move the graph in and out. So I'll show you that because that's really handy. But the other thing I want to point out in Desmos, let me see if am I in projector mode? Yeah, I was. Okay, the other thing that's really nice about Desmos, right? Once you're like, okay, this is a reasonable graph, and some of you are going to encounter things like this where it looks flat, but we know it's not because polynomials don't have constant sections. Okay, so something must be happening there that we can't really see. We might zoom in on. But if you click on your min, Desmos will tell you the point. So you don't want to use your graphing calculators. This is Ms. Cronky. Sure. Thanks. Alan, can you run to Mr. Spilker's real fast? Take the office pass. Here it is. Okay, so if you click on the min or max, it'll show you. And I'm okay if you round these like to the nearest tenth. So this would be negative 5.5 and negative 114.1. Okay, and then notice once I click on one of them, see how Desmos made all these little gray dots? It's picking out all my zeros and mins and maxes. So if I go through and I click on them, then I get this list of like all these interesting points that I should plot on my graph. So this would be really handy for you. Okay, right here where it looks like it's almost flat, of course there's my 0 at 0. Okay, and then this point is 0.5 to the right and negative 0.1 down. So it actually goes up to 0. It must bounce at the x-axis because it had an even multiplicity. It comes down to negative 0.1, and then it's going to come back. My next 0 is at 1. Okay, so when I draw that on the graph paper, I'm going to show that it dips, and I'll put this on the screen here. I'm going to show that it dips below. I'm not going to draw a straight line across because I know that doesn't happen. So we're going to kind of like exaggerate some of those really small mins and maxes. But I would use this, so this is how I decided how to graph on my graph paper. I figured out my mins and maxes, negative 114, and then I got to go up to 6. So my range is about 120. And I decided I wanted to do my picture horizontally. So what could I scale by so that I would get a nice chunk of 120 numbers. And it looks like I chose to scale by 5s. So that worked for me for my numbers. That may not work for you if you have to go lower than 114. Okay. So I chose to scale by 5s. I should be able to clearly see your scales, like what you went by. Okay, and that should be nice and neat. And I'll put this up here in a minute. But I use my min and max to decide that. Okay, and then my zeros, of course, are going to be between 0 and 9 because you're using the digits from your birthday. So then you want to spread out your x-axis. Okay, so let me pull over my graph so everybody can see it a little bit better. So after you graph it in Desmos and you're happy with the shape, you can play around with it. If you don't love it, then, change one of the signs. Instead of x minus 3, make it x plus 3. Or make a new, if you have repeating digits, make a multiplicity or take away the multiplicity. Okay, try something. Okay, so I just plotted, I used all those mins and max and zeros that I was just highlighting on Desmos, and I plotted them after I decided my scale. And then I just used my marker and I made a nice curve. Okay. Now, notice that one point right there, this is 0.5, negative 0.1. I probably have exaggerated that in my scale of negative 5. Okay. So what I would want to see is just you put a point below the x-axis. It could be really close to the x-axis. Okay, put a point right under the x-axis. But show that thing, I call it like an M, where it comes up, it turns around, and then it goes back up, turns around again. Okay, so show that characteristic. I'm going to take off on your graphs if you draw it like Desmos makes it look like a straight line across, a horizontal line right there. Okay. For my x's, because I only had to go for Newton from 6 to positive 4, I think. So I had to get 10 in there. I spread them out. I counted 4 squares, and then I marked a 1 and counted 4 squares and marked a 2. So I'm really scaling it by 0.25s. But so your scale on your x doesn't have to match your scale on your y. You don't have to write every single line down. I scaled by 5s, but I just wrote negative 10, negative 20, negative 30. Because it gets really crammed and stuff if you write too many numbers. Flip this yellow page over to the back side. Look at that bottom paragraph. Those are your expectations for your graph. Nice and neat. Please make it so I can read it. Your polynomial should take up the majority of the graph paper, so that's why you got to think about your scales before you start graphing it. Include the scale of the x and the y-axis. If you're labeling, I should be able to tell what your scale is, so you're okay. Label your min and max points. So again, it's okay to round what Desmos told you. So I have negative 2, negative 8.7. That's a rounded max or min. As well as your x-intercepts. Don't use pencil. Now you could use pencil to draw it, but then go over it with marker or colored pencil. Make it somewhat colorful. It's easier for me to read than when it's in pencil. And it's all about you. So if you want to add a little flair to your polynomial, go ahead and do that. Whatever you want to do. Okay. I use some fancy lettering, right? Little dots. Okay, that's my flair. It's so exciting. Okay, so I say this. Once I have this graph, answering questions 5 through 8 is super easy. I can pick out my mins and maxes. if I needed to do increasing and decreasing intervals, like I know it's increasing from negative 5.5 to negative 3.6 on the x's. So I could write that interval. And then I'll have a decreasing interval from negative 3.6 to negative 2. So if you have that graph, that's going to be real helpful in answering those questions. Okay, but Desmos does the hard work for you. You just have to figure the scale to make it look nice. Does anybody have any questions on their polynomial project? Due when? Friday. What else is due on Friday? The federal form. Thank you. Okay, with the rest of the time, you can work on your project. You can work on your review. You can work on homeworks you need to complete. This is